I'm on that Chapter 18B PowerPoint, Slide 5, where we're going to talk about the relationship between Q and KSP. Let's take silver chloride as our salt and write its dissociation in water. And for this particular reaction, we know that we can write KSP. That's going to be equal to the concentration of silver at equilibrium times the concentration of chloride at equilibrium. There may be also other cases where the concentration of silver and chloride is not at equilibrium, and we can calculate this product of of silver ion and chloride ion at any time. And if we do that at a time when we're not certain we're at equilibrium, we call that particular product Q. And the relationship between Q and KSP can tell us which way this reaction is going to tend to go. So if Q is equal to KSP, you might remember when Q and K are equal, we're at equilibrium. And in this case, we know that the reaction is not going to proceed in a large direction in one direction or another. Overall, the reaction is at rest. If Q is less than KSP, then we know that the reaction has not gone far enough and it's going to proceed in the forward direction. So we go from reactants to products, and we know if Q is greater than KSP, then we know that the reaction has gone too far, so to speak, and the reaction will proceed in this direction. So when this is the case, you should recognize under some circumstances when you mix two reactants, for example, and Q becomes greater than KSP, you're going to see the formation of a solid. And that's basically what we're doing in the question here at the bottom, which asks, what is the minimum chloride concentration in tap water that can cause precipitation? Well, what does that mean, precipitation? That means the formation of a solid. So if we mix together a certain concentration of silver ion and a certain concentration of chloride ion, will it form silver chloride salt, which will look cloudy in solution? It'll look like a solid's formed. This is really an easy problem to do. All you have to do is you're going to need to write KSP, which is 1.8 times 10 to the negative 10. And we're going to set that equal to the concentration of silver ion times the concentration of chloride ion. We're given a concentration of silver ion, right? Silver nitrate. When that's a soluble salt. All nitrate salts are soluble. So when this goes in water, you get full chloride ion, silver ion and full nitrate ion dissociated. So if I have 0.06 molar silver nitrate, then I'm going to have 0.06 molar silver. Now we know that in order for a precipitate to form, we're going to need Q to be greater than KSP. So we need this product to be greater than 1.8 times 10 to the negative 10. Let's see, this has got to be greater, so I'm going to write this, and I know my silver ion concentration is given to me. That's going to be 0.06 molar times a certain chloride concentration that we're looking for that will cause precipitation. That's it. We're just going to divide both sides by 0.06. And this will give us the chloride concentration that needs to be exceeded in order to cause a precipitate. So I'll just write this out, 1.8 times 10 to the negative 10. And I'm going to divide that by 0.06. 3 times 10 to the negative 9. That's not much. So I see that as long as my chloride concentration exceeds 3 times 10 to the negative 9th, and I mix that with 0.06 molar silver, we're going to get a precipitate.